Let's quickly discuss trigonometry. This is one big section in mathematics paper 2 that definitely needs to be revised very thoroughly. So let's start with ideas. Ideas are important. Studying is very much important so that when you look at a question, you immediately know what to do. If an angle is added or subtracted from 180 and 360, the one thing that comes into my mind very quickly is that I must remember my reduction formulas. If an angle is added or subtracted from 180, the first thing that quickly comes into mind is reduction formulas. 180 degrees as well as 360 degrees. Any angle that is more than 90 degrees, that angle must be reduced using reduction formulas. I must know that as general knowledge in my mind. Then if if two angles are added or subtracted from each other, then I must think about compound angles. So I may need compound angle identities to simplify those expressions where angles are added or subtracted from each other. What else do I know? If an angle is subtracted or added to 90 degrees, then it means I must think about application of co-functions. So that means these two, I'm going to use co-functions to simplify them. If you don't get ideas by looking at the question and reading through it, then it might mean that your preparation for the examination has not been thorough enough. The moment you look, these ideas must come into your mind. At the bottom part of this question, I've got general solutions. I need to know that in an equation, we have different types of general solutions that we have discussed. And this one here requires the application of co-functions. Then the last question, this is a general question. We need to find the maximum value of this expression. We have a look at that. This is a good example of a grade 12 Euclidean geometry question in mathematics paper 2. Let us have a look at the answers to this question. Number 1.1. If you see 180 plus theta or 180 minus theta, then you must know immediately that the 180 falls away, giving me tan squared theta. Here, the 180 falls away, giving me cos theta. One important item is that once you drop the 180, the remaining expression becomes positive or negative depending on the cast diagram. If you are writing an examination situation and you are under pressure, you can even use your calculator for this. In place of theta, put a number, any number less than 90 degrees. Let's say 1. Then type on the calculator cos 180 plus 1 and press the equal sign. Then you don't worry about the answer, you are checking whether it is positive or negative. You will see that this will be a negative cos theta. Then tan, in the same way, if you put a number in place of theta, any number less than 90, type on the calculator the tan of 180 plus theta, or in place of theta you have put a number, let's say 1, tan 181. You will check on the calculator will show you whether it is positive or negative. Remember, when you're in an exam, it's about getting marks. It's not about impressing anyone. You must get marks, that's all. Now, this one is squared. So the squared make it positive automatically, which means I have got tan squared theta. This is the first mark I must get, and this is the second mark I must get, just by changing those angles using the reduction formulas. We may also need to remind you using this question that if you don't want to go through the calculator one, then in your studies, make sure that you understand this diagram very well, that in quadrant 1, the angle is theta. In quadrant 2, the angle is 180 minus theta. In the third quadrant, the angle is 360 minus theta. Then, apart from that, we need to remember that in quadrant 1, all trigonometric values are positive. In quadrant 2, sine theta is positive. In quadrant 3, tan theta is positive. And in quadrant 4, cos theta is positive. So the cos of 180 plus theta is in the third quadrant, and in the third quadrant, cos is negative. So this must be a negative cos theta. Secondly, 90 degrees. If I see 90 degrees, the 90 degrees falls away. At the same time, sine changes to cos and cos changes to sine. So the sine of 90 minus theta is equivalent to cos theta. That is the third mark. If I don't continue with the exam but I've done this, at least I must get 3 marks for applying the reduction formulas and co-functions. Now, the next thing, once you apply your reduction formulas in the core functions, you now look for identities. The first, easier and most obvious identities are the grade 11 ones. The cos squared of theta plus the sine squared of theta equals to 1. And also the tan of theta is equal to the sine of theta divided by the cos of theta. These are the first ones. Then if I check these ones, I go on to check the double angles and the compound angles and so on. So in this case, I don't have all that. I've got tan, which is an identity. So these two are the same. I can add them into cos squared theta. Then this positive here is going to become negative because of this negative here. Then change the tan squared. My expression now looks like this. Sine squared theta over cos squared theta is replacing tan squared theta minus 1 over cos squared theta, which I got by multiplying these two numbers. Now I have fractions. What do you know about fractions? If the denominators are the same, you add the numerators. So in this case, my denominators are the same. Therefore, I'm going to simplify the numerators only. Sine squared theta minus 1. Then I want you to notice something from the first identity that we've mentioned. Now, in this identity, we can, if we transpose the sine theta to the right hand side, we get cos squared theta is equal to 1 minus sine squared theta. If you notice, like I have in this expression, that you are now working out sine squared theta minus 1 instead of 1 minus sine squared theta, then it means your identity is negative. This is equal to negative cos squared theta. The same thing happens a lot with double angles, but let's just stick to this question for now. So to show the full working out, we use factorization. So you are given, let me just do the working out here. You are given sine squared theta minus 1. Then you factor out negative 1. If you factor out negative 1, it will make the first one negative and the second one will become positive. This is how your expression look like. So if we rewrite this expression starting with the positive term, then it will be 1 minus sine squared theta. And 1 minus sine squared theta is the same as cos squared theta. So that's what we are doing here. So this part here is equivalent to cos squared theta. So replace it with cos squared theta, then divide cos squared theta divided by cos squared theta. Then this will give me the final answer to this question, which is equal to -1. So in preparation for exams, I must make sure I have a good and a clear understanding of how to apply reduction formulas, because they are always there in your examinations. Number 1.2. Now, question number 1.2. To answer this, take your expression here. These type of questions are also very common, always there in our exams. We make the trigonometric expression given the subject. So we are told that p sine theta minus 1 is equal to 0. Now we move the -1 to this side, then that will give us p times the sine of theta is equal to 1. Then you divide both sides by 1, you will get sine theta is equal to 1 over p. Now, if you do that, you are going to have two conditions here. The condition that we have, the first one, is that this statement says p is positive. P is positive. Then this one here tells us that cos theta is negative. Now, you take those two statements. We need somewhere on the grid where sine theta is positive but cos theta is negative. Which quadrant do we have where in that quadrant sine theta is positive but cos theta is negative? In that quadrant, you draw a triangle, and it is definitely quadrant 2. In quadrant 2, cos theta is negative, and in the same quadrant, sine theta is positive. This is the quadrant that we need. Then you draw a triangle. Your triangle is labeled according to trigonometric ratios. The sine of theta is equal to opposite divided by the hypotenuse. So in my triangle, on my opposite is 1 and the hypotenuse is p. Then we calculate the third line using the theorem of Pythagoras. That is how we answer this question. Once we're done doing this diagram, we can write down the answer. Number 1.2.1. We know that if there is 90 degrees, this means the cofunction. The 90 degrees falls away and the cos changes to sine. So this is the same as sine theta after application of cofunctions. Once you do that, the sine of theta, you read from the diagram, from the triangle that we have drawn. Sine is opposite of hypotenuse. The opposite is 1. The hypotenuse is p. Therefore, the answer for number 1.2.1 is 1 over p. Number 1.2.2, we need the value of cos theta. There is no ritual for this one. Cos is equal to adjacent divided by the hypotenuse. So in our triangle, the adjacent is the root of p minus 1 over p. And look, I have a negative here because this line is on the negative side of the x-axis. So this is the negative root p squared minus 1 divided by p. That is the cos of theta you read from your diagram. Then number 1.2.3, I want to find the value of sine theta 30 minus theta. If you see two angles that are being subtracted in brackets like this, let this remind you of the compound angle identity. I need the compound angle identities here. What are my identities? The sine of 30 minus theta equals to sine 30 cos theta minus cos 30 sine theta. Then remember, this is done without a calculator. So observe that this is a special angle, this is a special angle. So the sine of 30 and the cos of 30, we use the values of special angles. Then the cos of theta is what we calculated in 1.2.2. The sine of theta is what we calculated in 1.2.1. If we did not calculate those values, we can still read their values from the diagram. So I do substitution and simplify my expression to simplest form. This answers question number 1.1 to 1.2. So I need to know how to apply reduction formulas, and I also need to know how to deal with co-functions, and I need to know how to answer diagram type questions. And that was my answer for this part of the question. Right, question, we have answered 1.2, 1.1, 1.2. Let's do 1.3. Right, here you have a choice when you're answering an examination question like this. This side is the left-hand side, and this side is the right-hand side of your identity. So you choose which side to simplify. You simplify the left-hand side and make sure that the answer you get is the right-hand side, or you simplify the right-hand side and get the expression on the left. In some cases, you may need to simplify the left-hand side and the right-hand side and make sure that the two answers are the same at the bottom. This is direct application of the compound angle identity. We know that sine A plus B is equal to sine A cos B plus cos A sine B. Then the sine of A minus B is equal to sine A cos B minus cos A sine B. Then to simplify this, we need to be careful with the brackets because our expression is quite big. So we're looking at this one as one set of brackets to multiply, and this one is another. So using the FOIL method, if you are in an exam, you can also move fast to notice that these expressions are exactly the same, but this one is a positive and this one is a negative. That means it is a difference of two squares. So multiply those two expressions and then multiply these two expressions. That will be our expansion done in a shorter way. Application of difference of two squares. Let's say I've got A plus B, just to illustrate what happened here. Factor of A minus B. Now A times A gives me A squared. A times B gives me minus BA. Then B times A gives me BA. Then B times B is going to be negative B squared. Then from here, these two terms in the middle are like terms. They give us 0. So this is A squared minus B squared. So what we are saying is that if I get A plus B, factor of A minus B, if you notice that these expressions, this is a difference of space, you can simply multiply the first and the last only to get your answer. So that will be A squared minus B squared. So you don't have to do this full expansion. You can write your answer in short like this. So that's what happened here. Sine A cos A multiplied by sine A cos A. We got sine squared A cos squared B, sine A, then sine A cos B times sine A cos B. The same applies to the next one. We get this expression. That is what we have. Then from there, we can carry on to simplify this expression. using still the same idea of factorization. Now, if you look, I want this expression to look exactly the same as the one on my right hand side. So what we do is, this one here is equivalent to 1 minus cos squared, 1 minus sine squared b. Then in the same way, the cos squared a is equivalent to 1 minus sine squared a. That is the substitution I do. Then I remove those brackets and simplify my expression to simplest form. Once my expression is in simplest form, I then use difference of squares to factorize my expression and look the same as the one on the right hand side. Then my identity is proven. So our challenge that I probably want us to be clear about is, because when you are doing mathematics, it doesn't help you to just look at the answer and say, oh yeah, I see. The question you must ask yourself is, how did we get there? Why did we do what we did? So when I reach this part of my expression, after expanding the first brackets, then I did substitution. I am able to notice that in this expression here, if this expression is expanded, it's a difference of two squares. So it's going to be sine squared a and cos sine squared a and sine squared b. I can see that the expression on my right hand side does not have cos at all. So it then says to me, okay, for me to simplify this expression, it might be necessary that I remove this cos here, and I also remove this cos here. Why? Because in the expression that I'm getting at the end, I don't have cos. That is why I took out this cos squared and replaced it with that expression. Take out this cos squared and replaced it with that expression. Then from there you remove the brackets and simplify and factorize as a difference of two squares. Then your identity is proved. So your substitution in trigonometry must not be done just at random without any mathematical thought to it. If you do that, you are going to find yourself cancelling, starting over again, cancelling and getting frustrated at the end of the day. There has to be some little bit of some thoughts that I put as to why am I doing a particular substitution, and then do it. Number 1.4. Determine the general solutions to the equation. What are the general solutions to this equation? Now, there are many methods that can be applied to solve one mathematics problem. If we put up one here, it's not like a prescription. You can do it in so many various ways. We just don't have time to exhaust every single available option. But in this case, let's have a look. If you get an equation where there is one term on the left and there is one term on the right, one term is a sine something and the other term is a cos, no any other numbers added to the equation, just those two terms, then it means you can solve the equation by applying the idea of cofunctions. So how does the idea of cofunctions work? The formula is the cos of 90 degrees minus theta is equal to sine theta. Then the other one is the sine of 90 degrees minus theta is equal to cos theta. These are the two formulas that we can apply to solve this problem. Please remember the conditions. I don't have any other numbers added to this x equation. I have two terms only, one on the left, one on the right. Both of them, one is cos and one is sine. I can use cofunctions. You make a decision when you look at your two angles, which one you want to change using cofunctions. It is advisable to change one that has got one term, like in this case 2x compared to x plus 30. I would rather change 2x to make my calculation simpler. Now, to change sine 2x, you go to your formula for sine theta. Sine theta is the first one. It is equal to cos 90 minus theta. In place of theta, replace theta with the 2x, then you get the sine of 2x. This side, the cos of 90 minus theta, will become the cos of 90 minus 2x. That is our approach. So that means our equation will look like this. The sine of 2x is cos 90 minus 2x. The reason why we do this is because in a trigonometric equation, make sure that there is one trigonometric expression. You've got cos theta is equal the cos theta in the entire equation. You can't have cos theta, sine theta, tan theta in the same equation. Then it will become difficult to solve. We need the same trigonometric expression. Cos theta is equal to cos theta, or sine is equal to sine. Let's say for a moment I wanted to change cos. You do the same thing. I know that the cos of theta is equal to the sine of 90 degrees minus theta. Now, my angle for cos in this equation is x plus 30. So in place of theta, you put x plus 30. That means the cos of x plus 30 degrees is equal to the sine of 90 minus theta. In place of theta, you put x plus 30 degrees. This is also an option. Then when I solve the equation now, on the left side, it will be the sine of 2x. On the right hand side, it will be the sine of 90 minus x plus 30 degrees. This is my trigonometric equation. Then I can go ahead and solve it. So this is an option, but I didn't use that one in this case. I changed the sine into cos. Once you change one of them, it's like having cos A. If I say to you cos A is equal to cos B, then we expect A and B to be equal to each other. So we equate the angles. You don't divide. There is no division taking place here. The bracket on the left, 90 minus 2x, and the one on the right, x plus 30, they are equal to each other. Then immediately we add the general equation statement, n times 360 or k times 360. Then you solve in the normal algebraic expressions way. The negative 2x and this x, they give us minus 3x. 90 and 60 will become minus 30, because 90 going to the right hand side will become 30 minus 90, which gives us minus 60. Dividing the whole equation by negative 3 gives us x is equal to 20 plus n times 120. That is my first general solution. Now, the second one, we take the angle on the left, which is 90 minus 2x, equals to, then the second angle, we subtract it from 360. Why are we subtracting from 360? It's because our equation at this point is made up of cos. Cos theta is positive in quadrant 1 and that is where our first solution comes from. It is also positive in quadrant 4, and the measurement of the angle in quadrant 4 is 360 minus theta. That is why I'm subtracting 360 here. If this equation was sine theta or sine something is equal to sine something, then my second solution was going to be 180 minus theta, because the sign is positive in the second quadrant where it's sine 180 minus theta. So in this case, we use the 360 because it is cos. Now from here, you simplify generally the way we would simplify an algebraic expression and get our second solution. Then our general solutions equation is being solved. So something to take away quickly is that when you are solving the equation, make sure that these trigonometric expressions are the same. You can't have cos and tan and sine in the same equation. Find a way of substituting them so that you get cos only or sine only or tan only. In this case, we have applied cofunctions. What made it possible to apply cofunctions? The equation has two terms only, sine and cos, no any other numbers added or subtracted from it. There is one more video that we explained these equations. If you find that one, it is more examples that you can go through. Right, the last question, number 1.5. We want to determine the maximum value and the minimum value of cos 2x minus 2 cos x. Right, we need to simplify the expression first to its simplest form. And obviously, there are two terms here. So the only available option is to work with the double angle provided. We know that the cos of 2x is equal to cos squared x minus sine squared x, which is also equal to 2 times cos squared x minus 1, which is also equal to 1 minus 2 times sine squared x. Remember, our substitution must be guided by certain thoughts. We can't just grab an identity and put it there. You complicate your calculations. Now we need to simplify this, so we have to get rid of that expression so that we can have one angle magnitude here, which is x throughout. And the best option for us is 2 cos squared x minus 1, because I have cos x in this equation. So if I put sine here, then I'm going to have two different trigonometric expressions. So we have to substitute cos 2x with 2 cos squared x minus 1. Now the ideas that we are using here are coming from trigonometric, are coming from quadratic expressions. So let's say I have 2x squared minus 1 minus 2 times cos x, and our times sine x. Let's say I'm having this expression 2x squared minus 1 minus 2x, and I want to find the maximum value. I know that the one thing that I will definitely do is to express this in standard form. Then after expressing in standard form, I go on and complete the square. I have to complete the square. If you complete the square in a quadratic expression, it will look like this. F of x is equal to a factor of x minus p squared plus q. This is a quadratic expression after completing the square. So in this expression, we want to complete the square so that we can be able to then determine what the maximum and minimum are. So completing the square, I am taking it that you know how to complete the square already. If not, then you may need to have a look at how to do it and revise. So after completing the square, we can then figure out what our answer is. This 2 multiplies here and multiplies that last one. That's why 3 over 4 becomes 3 over 2. Then from this form, after completing the square, we can now read out what is our minimum and what is our maximum. So the maximum for this expression is 3 and the minimum is negative over 3. Then our whole trigonometry question is being answered. This is the complete question as it appeared in this particular examination paper. So to quickly go through what ideas we have used in answering this question. So the first one, you look for reduction formulas. So this is reduction formulas, and that one also there. Those two we have applied reduction formulas to solve them. Then apart from reduction formulas, we also applied core functions. If I see 90 minus theta or 90 plus theta, then it means core functions. After core functions, you are followed by identities. The tan theta is equal to sine theta over cos theta, cos squared theta plus tan squared theta is equal to 1. And then you simplify. Number 1.2, this is a diagram type question, and you must you must draw a diagram in one quadrant. The quadrant in which the diagram must be drawn is determined by the conditions that are given in the question. So in our case, they said that cos theta is less than 0. That means cos theta is negative. And we know that cos theta is negative in quadrant 2 and also in quadrant 3. Then another condition that is given is the sine theta. This expression here, we said you divide both sides by p, then it's gonna give us the sine of theta is equal to 1 over p. And p is positive here, so that makes sine theta positive. And sine theta is positive in quadrant 1 and in quadrant 2. So the one quadrant that satisfies both conditions, cos theta is negative but sine theta is positive. That is quadrant 2. So you draw a triangle in quadrant 2 and label it according to trigonometric ratios and then simplify your expression. Then here we say different angle is being subtracted. Think of compound angle identities. Think of compound angle identities. Number 1.3 is a very nice idea. There is some reasoning that needs to be applied when you're solving a problem. Number 1.4, we said if you get a trigonometric equation where there are only two terms, one is cos and one is sine, then the equation can be solved by using core functions. Then the last question, to determine the maximum and minimum value of this expression, make sure the angle magnitude here is the same. You must have x throughout, and we achieved that by using double angle identity. Then after using double angle identity, we went on to complete the square. So apply double angle identities and then complete the square. After completing the square, you can then read what the maximum and minimum values are. So that's my one examination question, a very good example of an examination question on trigonometry, grade 12 mathematics paper 2. So I'm not so sure if you were to do it, how many marks do you think you would get? But obviously, with the practice, studying and revision, things should work out for the good at the end of the day. Thank you.